word problems with you because I know those are usually the trickiest ones. Carnival manager counted 275 ticket receipts. The price of an adult ticket was $11.50. Price of a student ticket was $10. Let X represent the number of adult tickets and Y the number of student tickets. So we need to make two equations because we have two unknowns. So the first equation I'm going to make is going to represent the dollars. It's $11.50 times each X, so times each adult ticket. Okay, you get 10 adult tickets, and you made $115 in the adults. Plus $10 for each Y ticket, for each student ticket. And the amount of money you make from the students, the amount of money you make from the adults plus the amount of money you make from the students, that should equal $2,930. So there's one equation. Now another equation I can make is, well, you take the number of adult tickets plus the number of student tickets. That should equal 275 tickets total. Now you've got a system of equations you can solve. Okay, I guess I can do it real quick. I would use elimination, multiply everything by negative 11. Let's do negative 10. Let's make the y's cancel out because that'll be cleaner. So you get negative 10x minus 10y equals negative 2750. That's what the bottom equation looks like. The top equation still looks like this. And now you can smush them together with addition and add the top to the bottom. So you get 1.5x equals 2930 subtracted by 2750. We get 180. So I think you know how to finish that one out. Divide both sides by 1.5. So you get 120 for the adult tickets. Plug that into this equation, or that one, I guess, to find out the number of student tickets. And when you do that, you should get 155 for Y. Wait, what did I say? 155. All right, there's your ordered pair, Newton. Take it. Okay, let's try another one. A rickshaw company counted 39 ticket receipts last week. These are the most exciting examples. The price for a weekday ticket is $7, and the price for a weekend ticket is $9.50. The rickshaw driver collects a total of $333 for the week. Same type of thing, right? Make an equation for the dollars where X is the number of weekend tickets. So, oh man, watch out. They threw that at you in a different order. 9.50 times X, because X represents the number of weekend tickets and is $9.50 for each weekend ticket, plus $7 for each weekday ticket. That should equal the total amount of money they made for the week, $333. And then they said there was 39 tickets total. So if you add the weekday and weekend tickets, you should get 39. Okay, you could rearrange these, solve using substitution, but I always found the multiply everything by negative 7 to make those y's cancel out. So 39 times 7, that's negative 273. I always found the elimination method was easier. So we're just adding the tops and the bottoms. So you get 2.50x. Those cancel out by design. And then 333 subtracted by 273. That makes 60. So the last step is divide both sides by 2.5. So we get x is 24. And so if there was 39 tickets total, then y should be 15. Oh, wait. They just wanted the equations. Dang it. Okay. So these equations are right. We just need to rearrange them to get it the way they had it. Sorry. So that solves it, but that's not the question they're asking us. I got to rewrite this one. They want us, this one was x plus y equals 39. So if you get y by itself in this bottom equation, it's nice and easy. You just have to subtract x from both sides. Now, trying to get y by itself up here, a little bit more involved. They say it's good to get rid of decimals when you can. I guess so. When When coefficients contain decimals that can be easily converted to whole numbers, it's good to convert them. So they're saying to get rid of the decimal by multiplying. I think they're trying to say multiply everything by 2. Okay, because 2 times 9.5, that makes 19. You no longer have a decimal. Or you can multiply by 10. You know, there's an infinite amount. I'm not sure I'm super jazzed up about this question. This is 9.5 times 2 is 19x. 2 times 7 is 14y. And then 2 times 333 is 666. You could have multiplied everything by 10 too. This looks good. Y equals negative x plus 39. That's what we've got. We don't have 15y though, so let's keep looking. This y equals negative x plus 39. That's this one right here. Now this one, if you get y by itself, you can rearrange by subtracting 19x from both sides. That's what we got here, right? Negative 19x and then plus 66. You could rearrange them. Yeah, so the other way, I guess, of doing that is take those two that are definitely right, the first ones we make, graph them in Desmos, and then you have to graph each of these options to see which one matches up. Yeah, so not easy, but it is good practice to know how to like take an algebraic equation and manipulate it, because there's going to be plenty of times, you know, if you work with some sort of mathematics in the future, where you see something and you're not sure if it's the same thing you got, or if you're not sure if it's the same equation you've been working with. You need to be able to rearrange it to see if it's the right